So vector is basically an arrow. And just like every other arrow, it basically points to something. That's what a vector is. It must have some direction, because without it, it doesn't make sense to have an arrow to have a direction. So that's the first thing. A vector must have a direction. That direction, whatever it goes in, obviously we are dealing with vectors that are straight. You can't have a bent vector. Like ये एक vector नहीं हो सकता. But what it can be is a collection of small vectors that bend along the path. Okay, so that is what any journey can be. It can be a direction, a collection of vectors. So that's the first thing. Now, another important thing to know about vectors is कि अच्छा चलो ये यहाँ से यहाँ पे point कर रहा है, but you can have another arrow that points in the same direction. What is the difference in these two vectors? And they have the same direction, but there is still a difference, right? And the difference is in size. So we know कि वेक्टर की डायरेक्शन होगी और वो दो वेक्टर्स की सेम हो सकती है, लेकिन ये दोनों वेक्टर सेम नहीं है. लेट मी कॉल दिस वेक्टर a and this vector b. So a and b are not the same. They just have a common direction. So what is the difference? It is the size, or the what we call magnitude. So while the direction of a and direction of b is the same, the magnitude is different. So we'll say कि ये उसी डायरेक्शन में थोड़ा ज्यादा जा रहा है, वो उस डायरेक्शन में कम जा रहा है. इट कैन बी अ वेक्टर, कैन बी अ होल जर्नी इन इटसेल्फ. मतलब आप लाहौर से इस्लामाबाद जा रहे हो एक ही डायरेक्शन में, बट मे बी समबडी ड्रॉप्स ऑफ इन जेलम. सो वो उनका जो जर्नी का वेक्टर है, दैट इज वेरी डिफरेंट फ्रॉम द जर्नी वेक्टर ऑफ समबडी गोइंग फ्रॉम लाहौर टू इस्लामाबाद, जस्ट इन द सेंस ऑफ साइज. हो सकता है उनका डायरेक्शन सेम हो. हाउ डू वी मैथमेटिकली शो दिस? द डायरेक्शन वी शो इट यूजिंग an angle. So theta is the general symbol for angle, and that angle can be usually it is anti-clockwise from. Okay, so it's basically done like this, that this is east, तो यहाँ से ऐसे को एरो करेंगे तो ये थीटा आएगा. ठीक है. सो यहाँ से हम किसी भी एरो को चेक कर लेते हैं, किसी के वेक्टर को डायरेक्शन चेक कर लेते हैं. बट इट डजंट हैव टू बी लाइक, यू कैन हैव एनी अदर सेंस ऑफ डायरेक्शन एंड दैट्स परफेक्टली फाइन. हमेशा ईस्ट को रखना जरूरी नहीं होता. यू माइट हैव स्टडीड अबाउट बेयरिंग्स इन ओ लेवल्स. सो बेयरिंग्स में भी you just take the sense of direction from north instead of east or anything. Okay, so that again has its own merits. So just like that, this is another way of measuring it, and that's how you will usually state it in the exam. So magnitude is basically the length. So we usually show it as this. So we can say that magnitude of A is in this straight lines in A is not equal to magnitude of B. Now, you might notice that this is the same two lines that we used to show modulus. Okay, when we had trigonometric graphs, or when we had, we used to use modulus. So this is the same line, and in fact, it means the same thing here, except there's some physical aspect to it कि ये सिर्फ नंबर नहीं है, ये actually that number means the size of the vector. अब कोई भी वेक्टर है, you can easily show it to be in one direction or in the opposite direction. So उसके लिए what we do is we use the signs. So the sign tells us that what side it's going to. So there is a positive sign and there is a negative sign. So that just shows that they're opposing each other. So if I say there is a vector A and there is a vector minus A, so all I'm saying is that if this is A, then the other vector is exactly the same size as A, it's just in the opposite direction. And again, exactly opposite direction. Okay, so that's what opposite vectors are. के positive और negative सिर्फ उनको opposite कर देता है, और करता क्या है? It basically flips the direction. All right. Now similarly, I'm just talking about extreme cases here. There can be a vector. This is a zero vector. So a zero vector is basically that might have a direction. So उसकी direction तो हो सकती है, but उसकी length zero है. So if the size or magnitude or length is zero, it's a zero vector. So you can't really show it. You can say that it is a vector, but obviously उसकी कोई length नहीं है. Similarly, you can have a unit vector. Unit vector क्या होता है कि आपके vector की length 1 हो जाती है. ठीक है. So that is your unit vector. और इसको usually हम एक hat से show करवाते हैं. So if you have a vector with a hat on top, this hat, this shows that it's a unit vector. So unit vector simply is a vector that has the same direction as something else, except it's in the it's just a very small 1 centimeter या one length, जो भी आपका यूनिट है उतनी उसकी लेंथ है, and that's your vector. तो इसका फायदा क्या होता है? Basically unit vector tells us the direction. साइज की वो फिक्र नहीं करता, वो हमें कहता है कि डायरेक्शन क्या है. तो लेट्स सपोज मैं कहता हूँ कि मैंने गुलबर्ग जाना है, तो आई माइट पॉइंट विद माय फिंगर और माय हैंड कि भाई इधर गुलबर्ग है, इधर चले जाए. ठीक है ना. ऑब्वियसली मैं ये तो नहीं कह रहा उनको कि जितने मेरे हाथ की लेंथ है इतना आप ट्रेवल कर लें 1 फीट. Basically I'm telling them in this direction, just go and you will find it. I am not telling them about the size or the magnitude at which they have to go. It is just this direction, and that is what they get from the vector. So a unit vector just tells us the direction. So what do we do? How do we get a unit vector? हमें कोई भी vector मिलता है, हम उस vector को so basically एक unit vector बनाना ना, मैं एक वेक्टर लूंगा और उस वेक्टर को उसकी लेंथ से डिवाइड कर दूंगा. बेसिकली जितनी उसकी लेंथ है ना उतने मैं उसके चंक्स बना दूंगा 1 सेंटीमीटर के, तो मुझे वो वेक्टर मिल जाएगा. और इन अदर वर्ड्स यूनिट वेक्टर टेल्स अस द डायरेक्शन एंड मैग्नीट्यूड टेल्स अस द साइज. तो कोई भी वेक्टर जो है उसके दो पार्ट्स हैं. देयर इज द वेक्टर ए, एक उसका मैग्नीट्यूड है और एक उसका डायरेक्शन है. And that is what makes any vector. Okay, so a vector is anything that has a magnitude, which is this part. This I am highlighting it in yellow. It has a magnitude and it has a direction. So जो चीज हमें magnitude बताती है उसको हम इस तरह straight line में show कर देते हैं, और जो चीज हमें direction बताती है उसको हम hat के साथ show कर देते हैं. And when you combine these two, you get a vector. समझ आ गया कि vector क्या होता है? It has two parts और दोनों आप अलग-अलग निकाल सकते हो. अच्छा, अब फायदा क्या होता है? अगर दो वेक्टर्स का मैग्नीट्यूड सेम हो तो ठीक है, उनका मैग्नीट्यूड सेम है, कोई और स्पेशल बात जरूरी नहीं है उसमें. बट अगर दो वेक्टर्स का ये यूनिट वेक्टर सेम हो तो इसका मतलब है दे आर पैरेलल. पैरेलल वेक्टर्स हैव सेम यूनिट वेक्टर, बिकॉज यूनिट वेक्टर डायरेक्शन बताता है. तो एक वेक्टर है ये और एक वेक्टर है ये, इन दोनों का यूनिट वेक्टर एक ही डायरेक्शन का होगा, क्योंकि वो सिर्फ डायरेक्शन बताते हैं, लेंथ तो बताते ही नहीं है. तो इस वजह से हम कहेंगे कि ये दोनों आपस में पैरेलल वेक्टर्स हैं. ठीक है, द साइज कैन बी डिफरेंट, बट हम करते क्या है, हम कहते हैं कि दैट मींस यू कैन शो वन वेक्टर, लेट्स सपोज देयर इज वन वेक्टर a and the other vector b, and if a is parallel to b, so notice these symbols, if a is parallel to b, then you can say that a is maybe 5 times b, and this arrow is supposed to show that it's a vector. So I can say कि अगर b की length है 2 और a की length है 10, so I can say that because they're the parallel vectors, a is 5 times b or b is 1 by 5 times a. सही है ना? So basically any vector that is parallel, you can show them as a relation which is a equals to kb. और ये रिलेशन बहुत फायदे का है क्योंकि it allows us to find other vectors just given कि उनका यूनिट वेक्टर सेम है. ठीक है, तो as long as they're parallel you can use this. हाँ, अगर वो एंटी पैरेलल हो जाए तो उसका मतलब है कि उनकी डायरेक्शन ऑपोजिट है, बाकी सब सेम है, तो उसके अंदर आप माइनस के भी कर देते हो. ठीक है, बट पैरेलल और एंटी पैरेलल we just deal them as it is, यही कहते हैं हम उसको. अच्छा, तो ये समझ आ गया कि एक वेक्टर को आप दूसरे पैरेलल वेक्टर से कैसे रिलेट कर सकते हो. यू कैन जस्ट से दैट इट इज दिस मेनी टाइम्स द अदर वेक्टर, और उससे आपको उनकी या जी जी पूछें.
So sir, जो symbol है the hat one, that's for the unit vector and that's also for the direction, right?
Yeah, it tells us the direction. Yes.
Okay, thank you, sir.
Yeah. Now you can combine vectors, but because vectors tell us the direction, we have to add them in the way कि उनके unit vector और magnitude दोनों add हो. तो उसके लिए the easiest way to do this is to use the graphical method. So let's suppose मेरे पास एक vector है, I'll just draw it here. Let's suppose ये vector है, and let's suppose I have another vector which is this vector. So to add them together, what I'll do is I will take this one point it at the ending point of this thing. This is called head to tail method. So what I'm doing is I'm saying, अच्छा ये vector है, ये A से start हुआ, B पे end हुआ, और वो B से start हुआ, C पे end हुआ. So what is AC? AC is simply a journey from A to C, which means you go from A to B, and then you go from B to C. So you have basically traveled from A to C. तो मैं कह दूंगा कि ये मेरा resultant vector है. ठीक है, तो ये मेरा resultant vector है. और ये मुझे vector कैसे मिल रहा है? I'm just adding them up graphically. Obviously, this resultant vector has a angle, and it also has some what you say, sense of magnitude. Okay, so that's how I can add or subtract vectors. Subtract में क्या करना होता है कि आप इनको ऐसे subtract नहीं कर सकते, आप इसको opposite करते हो. Let's suppose मुझे AB minus BC करना है, ठीक है. So what I'll do is I'll take a vector that is exactly the same as this vector BC, लेकिन मैं इसको opposite ले लूंगा, कि उसके opposite जाना है मैंने, उतनी लेंथ में opposite जाना है मैंने. तो मतलब I यहां से B से शुरू करूंगा, बट मैं इसको opposite ले जाऊंगा, और ये जो मेरा वेक्टर आएगा ये मेरा AB minus BC हो जाएगा. ये मेरा रिजल्टेंट वेक्टर है. तो दिस इज AB plus BC, and this is AB minus BC, because I'm going the exact opposite of what I would go in BC. ठीक है, तो ये मेरे पास वेक्टर बन जाएगा, जो भी एक वेक्टर नया बनता है. So that's how you add them. You don't actually subtract vectors, you basically just flip the direction. Can you guys hear me properly?
Yes, sir, I can.
I mean, you can't. So let me give you a diagram. Now they're saying that OA is A and OB is B. Okay. Then M is midpoint of AB and N is midpoint of OA. Okay. Sorry, it's saying N is in a way that ON is 1/3 of AB. So you don't really know if it is indeed half or not. We just know this thing. Okay. So now try to figure out what OP is. अब इसके लिए I know that OP is parallel vectors की तौर पे शो करवाने की कोशिश करता हूँ. I know that OP is parallel to OM. Because क्या है, O से M जाना है, रास्ते में P आ रहा है. So you take a vector from O to P or you take a vector from O to M, they are parallel. Direction तो उनकी same है ना, and as long as they have the same direction, they are parallel. I know it's a little different from the definition of parallel lines that we see in geometry. कि जी वो दोनों मीट नहीं करती, यहाँ पे तो वो एक दूसरे के ऊपर impose हुई है. So that's what in vectors parallel simply means they have the same direction. That's it. So OM and OP have the same direction. We can see that from the diagram. We can say that OP is parallel to OM. Similarly, we can say that ON is parallel to OA. We can say that, right?
Yes, sir.
Okay. Now let me convert it. Let me say that OP is just use any symbol. Let's say मैं कह देता हूँ KOM, or
Sir?
ON is equal to G.
Sir, can we say that BP is parallel to BN?
Yes, we can. We can.
Okay.
ठीक है, हम कह सकते हैं, हम उसको लिख लेते हैं BP is parallel to BN, और हम उसको कहते हैं that BP is equal to, I don't know, JBN. ठीक है, क्योंकि वो KOM है, तो ये
parallel to BA.
BN is parallel to what? BM is parallel to BA. Yes,
Yes.
we can say that. अच्छा, now let me try to figure out कि इसको हम कैसे करेंगे किसी और की फॉर्म में. Like अच्छा, एग्जाम क्वेश्चन में उसने क्या बताया? So let's just go with this. Is it possible for us to figure out what ON is? ON कितना होगा? या OM कर लेते हैं पहले. How many A's and how many B's is OM? Now I can say that if I want to go from O to M, I can go from O to A and then I go from A to M. I can say that, right? I also know that going from A to M is same as going halfway from A to B. I
Is
can
it
say
not
that,
one?
right?
Is it not
Because
1/3?
no, M is in the middle.
M is the midpoint of
Okay.
O, B and A.
AB. Yes. Okay.
Yeah.
And so
Okay.
N is the midpoint
So
of OA, right?
it's not. It's not.
It's not. It's 1/3.
We just know that AN is 1/3 of AB.
Okay.
That's all we know. Yeah. Now, what is AB? I can say that AB is like going from A to O, then going from O to B. Now, what is OA? OA, as we know, is A. What is OB? OB, we know, is B. What is AO? Now, O to A is A. So, A to O will be opposite of that.
Minus A.
Minus A, yes. And now we have OM as half B plus half A. And we have found it. OM मिल गया तो OP बड़े आराम से निकाला जा सकता है. OP is just K times this whole thing. Right?
So please could you explain this example again?
Which part?
Sir, वहाँ से OM से.
OM से. So basically I wanted to find OM. And OM, I know, is going from O to A, then going from A to M. So I'm looking at the map here. Similarly, going from A to M is same as going halfway to A to B.
Yes, sir.
And going from A to B, I don't have a direct path, but I do know that I can just go from A to O, then O to B. Right? So I'm just trying to figure a way in terms of OA and AB. तो मुझे यहाँ से मिल गया. I now converted it. I have everything in the form of OA and OB because that is what the examiner wanted me to do. You have to make sure that everything is in the form that they have given to you.
Yes, sir. I got it. Thank you.
Yeah. So once you know the path, it's really easy to do it. Now, let me try to figure it out. If we wanted to find in terms of J, अभी तो हमने K की फॉर्म में लिखा ना, अगर हमें J की फॉर्म में करना हो तो B कैसे करेंगे? हम OM को क्या कह सकते हैं? मैं कह सकता हूँ कि अगर मैंने O से P जाना है तो मैं पहले O से B चला जाऊं और फिर B से P चला जाऊं. I can say that, right? I'm just doing the same thing but from another perspective. And going from O to B is just OB, and going from B to P is J times Bn. And what is J times Bn? It is, if you want to go from J to Bn, all you have to do is B से मुझे अगर N पे जाना है, so what can I do? Can I find Bm in some way?
Sir,
Bn. I can use this. I can say that going from A to N, क्या होगा? B से N आपने जाना है.
सर आप AB plus 1/3 AB कर सकते हैं.
हाँ, तो आप बेसिकली ये कह रहे हैं कि आप B से N जाना है आपने, आप पहले B से A चले जाओ और फिर A से N चले जाओ, है ना?
Yes.
So B
Yes,
से
sir.
A we just found it. B to A we found it. It was देखो, O to B is B. B to A we just found that it is opposite of this. So it is plus A minus B. And A to N is 1/3 of AB. And AB I know is, I found it already. It is minus A plus B. And now I can just simplify it and I will find OP. And that way I'm able to do it.
Sir, but you still have J to find, would you not?
Yeah, we won't be able to find J or K because we don't have any numbers.
Okay.
Sir,
Okay.
I've gotten a bit confused.
With what?
From sir OB plus J, sir, I get the B to A and then plus A to N. But sir, उसके बाद वाले step में I've gotten a bit confused.
B to A is opposite of A to B, right?
Yes.
So I have A to B here.
Yes, sir. Thank you.
So I'm going to give you a question and I would like you to do it. Okay, so how do we know that? It's because we know that this line is parallel to this line, and that means this is also parallel to this because it's right in the middle. Okay, it's going from the opposite side. Okay, that's how we know. We can divide the hexagon into two equal parts, equal parallelograms through this. Okay, that's how we know. Now, what is it saying? Express FD, CD, and BE. FD, CD, and BE. Yeah. So if you want to find FD, for example, now what information do we have? We want to show everything in the form of AB, BC. Okay, these are the two that we want to show everything in. So FD over here, like this whole portion, it is simply going from. So how I would do it is that I'll go from F to E because that is opposite and parallel to B to C, and then E to D, which is exactly opposite of AB. Okay, and that way I would be able to get it. So
that is what I did too.
Yeah, so I think that's fine. So FD is going to be, I'm going to make a path from F to E and then E to D. And using that, I can say that, okay, F to E is just as B to C, it's parallel, so it is the same. And E to D is just the same as, yes.
So what I did was that I said that F to E is the same as A to B because all the sides are equal.
F to E is the same as A to B in terms of size, but not in terms of direction.
Oh, okay. In terms of direction,
okay,
B to C is the same.
It is equal to B to C. Yes. All right. Same for CD. Same way, you are just going opposite to. So how will I do it? So DC. So what I'll do is I'll just make a point in the center here. And I'll be like, okay, I have to go from D to this point, and then I go from here to here. And when I do that, I'm basically going from D to, let me call it O. So D to O is same as C to B, right? And O to C is same as A to B.
So their direction is not the same.
Direction is the same. Because what I'm doing here is that I'm dividing this whole thing into equal parts here. So this thing is going to be, if I draw it like that, and I draw this like that, I know that these are all equilateral triangles. So that's just a hexagon, the way it is. So I can say that, okay, D to C, C to D is going from C to D will be going from C to O first, which is opposite of A to B, and going from O to D, which is the same as going from B to C. So C to O is negative P and O to D is plus Q. So that's what I know. That's C to D, right? Similarly for BE, I'll know that going from BE, how do we do that? BE is 2 times CD. I can see that, right? Going from B to E is just like going from C to D twice. Do you agree?
Yes.
So with that in mind, I can easily say that I have C to D, so it's going to be 2 into minus P plus Q. That's how I would know this. Okay.
Yes. But can you go to the B part?
Good. Now let's do the B part. We know that P is a unit vector. Okay. So the length of A to B is 1. So evaluate A to C. So going from A to C, I can say that I'll go from A to O and then I'll go from O to C. And what is A to O? A to O is just like B to C and O to C is just like A to B. So I'm just replacing them. And B to C is Q and A to B is P. And so I know it's a regular hexagon. That means the length of this is, because it's P plus Q, it's going to be length of AC is same as length of AO plus length of OC. Actually, no, that's not the case. ऐसे नहीं होगा, because that's not how modulus works.
कोसाइन यूज हुआ है
मैं सोच रहा हूँ इसको कैसे करेंगे. हमें एंगल साइड निकालना होगा. हमें ये लेंथ चाहिए. So this is the length that I want to figure out. I know that these are all equilateral triangles. So this is 60, this is 60, this has a length 1, this is a length 1. So I can easily find this one. Yeah, it is pretty easy. I have two sides and one angle, so I can find the cos using the cos rule. Yeah, pretty simple. Do you get it?
No, sir. Can you please do it?
Sure, of course. So I have a to c squared is equal to a to o squared plus o to c squared minus 2 times a to o times o to c times cos of the angle between a, o and c. So a to c squared is equal to AO, the length is 1, so 1 squared, plus again OC is length 1, 1 squared, minus 2 times again 1 and 1, times cos of 120. What is cos of 120?
Minus 1 over 2.
So it is 1 plus 1 minus 2 into minus 1 over 2. So it's going to be 2 plus 1, that is going to be 3. AC squared is 3. So what is the length of AC? It is just square root of 3. That's it. We get it?
Sir, I'm still confused.
In what part?
B part.
B part में मैंने ये किया है that I made a triangle. Now I know that these are all equilateral triangles. So using that, I have found the angle between A, O, and C. And that is 60 plus 60, 120. And using that, I basically have a triangle in which I know one side is 1. The other side is also 1. This is the third side I don't know the size of, and this is 120 degrees. So I just applied the cos rule. We also call it extended Pythagoras theorem.
Oh, okay.
Yeah, so that's how we do it. All right. So C part में क्या करेंगे? AX चाहिए हमें. X कहाँ पे है? Okay. So what do we know? We know that BX is KBE. So this is just like the other day when we did this question. कि AX चाहिए तो AX is just B to A plus A to X is equal to B to A plus A to B. ठीक है? यहाँ से हमें मिल जाएगा. सही है? या कर दूँ? I can do it. So this one is you want to find AX. Now I know that BX is going to be KBE. That's given in the question. Now I know BE. We have already found it. So I'll just plug that in there. So it's 2 times minus P plus 2Q. Okay. And BX is nothing but going from B to A, then B, A to X. And there I have AX hidden in there. So I'll just put that in there. So AX is going to be minus 2KP plus 2KQ minus BA. So what is BA? It's plus AB, right? So AX is going to be minus 2KP plus 2KQ minus BA, which is plus B. So I can just simplify this now. So that's the main gist of what vectors are and what vector questions are. Position vector is a concept that instead of having a randomly moving around the space, we just keep one reference point. Okay, so O, for example, O is our reference point. So whatever we do it with reference to that point. So I'll give you an example. Let's suppose we have this question, and now we want to show this. So they're saying express OR in terms of AB. Okay, so
Sir,
we know that, yes,
what is A plus 2B? Is it RC or OC?
A plus 2B is OC.
Okay.
Other information that we have is that AR is equal to K times AB, and OR equals N times OC, which is pretty simple. So we want to find OR in terms of K. Okay, so what is OR? We can say that OR is O to A plus A to R, right?
Yes.
So, and what's A to R? It is this thing. So I can simply be like that. It is OA plus K times AP. And what is AB? AB, I'll now introduce the position vector thing. That if you have AB and you have a reference point, for example, O in this case, you can simply be like that AB is OB, like the second point, minus OA, the first point. So you can simply convert it. Although there's no को बहुत ज़्यादा साइंस नहीं है इसमें. आपको पता है OB क्या होता है? O to A plus A to B. So I just rearrange that to get this. So it's easily possible to convert anything to position vectors. So it's going to be OB minus OA. I already know what OA is. It is A. I already know what OB is. It is B. So now I have my answer. It is A minus KA plus KB. And this thing I can simply be like, okay, 1 minus KA plus KB. And that's how I know. Then they're saying find OR in terms of N. We have to involve N somehow. So what is OC? We already know what OC is. OR is N times OC. And what is OC? It is A plus 2B. So you just plug that in there. And there you go. You found it. NA plus 2NB. And that's it. बहुत ज़्यादा science नहीं है इसमें. How do we use this idea of what vectors are and reconcile it with graphs that we have seen? उनको हम कहते हैं IJ vectors. आपने देखे हैं? So basically we have to find, basically convert any vector that we have to its components in X and Y. अब X क्या होता है? X is your obviously something that's parallel to the X axis, and Y is obviously parallel to Y axis. So they are coordinates of where that thing is with respect to origin. ठीक है? In the direction of X and in the direction of. Now what we do instead is that instead of doing it like that कि अच्छा ये X है और ये Y है, कोऑर्डिनेट ज्योमेट्री में लेट्स सपोज ये पॉइंट था और ये पॉइंट 2 3 है, तो इसका मतलब होता था कि you go 2 steps in the direction of X and you go 3 steps in the direction of Y, and you'll get to this point, right? Now this same idea can be represented in terms of direction, in terms of vectors. That if this point is P, I can say that if you want to go from O to P, you go 2 steps in the direction of X and 3 steps in the direction of Y, right? And the direction vector is this thing with hat, right? Now just to make sure कि बहुत ज़्यादा confusion ना हो, हम इनको X hat या Y hat कहने के बजाय I plus J कह देते हैं. So J is just the unit vector that tells me direction of Y, कि Y किधर को जा रहा है, and I is the unit vector that tells me कि X किधर को जा रहा है. बस that's it. कोई इससे ज़्यादा नहीं वो करते. तो इसका मतलब हुआ कि अगर मुझे ये एक पॉइंट है P और एक पॉइंट है Q और इसके कोऑर्डिनेट्स हैं -3 and 7 फॉर एग्जांपल, एंड आई वांट टू फाइंड QP, तो मुझे QP को देखने के लिए बड़ा आसान है कि मुझे Q से P जाना है. तो एक ऑप्शन क्या है मेरे पास? एक ऑप्शन ये है कि मैं Q से P जाने के लिए पहले मैं Q से O आऊं और फिर O से P चला जाऊं, राइट? So what is that? That's simply going from Q to O is nothing but the direction that we have, the coordinates that we have. Q to O is negative of -3 and 7, right? And OP is +2 and 3. क्या आपने 2 steps in X जाना है, 3 steps in Y जाना है? अब इसी सारी चीज को मैं एक और तरह से भी कह सकता हूँ. Instead of involving O every time, I can simply be like, okay देखो, आप यहाँ पे हो, आपने यहाँ जाना है, go this many steps in X and this many steps in Y. And that makes the diagram so neat. There is only 2 vectors that you have to consider. कि X में कितना जाना है, Y में कितना जाना है, बात खत्म. किसी और को, O को, P को, किसी थर्ड पॉइंट को लाने की जरूरत ही नहीं. सही है ना? And that is what we'll do है. We'll say, अच्छा देखो, आप Q से P जाना चाहते हो, आप -3 पे हो इस वक्त. Go 3 steps in this direction and then 2 steps further. So basically you're going 3 steps in I plus 2 steps in I. Similarly for Y, go, you are at 7, you want to go to 3, so go 4 steps in J, but in the opposite direction. नीचे चले जाओ 7 steps, और 4 steps नीचे चले जाओ, और 5 steps आगे चले जाओ, आप पहुंच जाओगे अपनी जगह पे. 5I plus -4J. That is my direction of Q to P. I don't have to involve O in this case, and my diagram is really simple now. So मैं सिर्फ X और Y में deal करना अगर चाहूँ, and I want to just have straight lines and that are just parallel to X-axis or Y-axis, and I can use the idea of coordinates to do this, I'll simply be like I और J में deal कर लेते हैं. ठीक है? So what is I? It's the direction vector of X, and J is the direction vector of Y. जी बताएं.
जी, sir, I get the 3 steps. I don't get कि अगर हमारे पास ना 7 लिखा है, why did we get like, sir, मैं इसमें थोड़ा confused हुई हूँ.
Can you elaborate a little bit? कहाँ पे confused?
Yeah, okay. So basically, I get कि we have to move 3 steps, but we move 2 more steps because वहाँ पे P पे 2 लिखा हुआ है दोनों के X में.
Yes.
But so then we move 7 steps and then we move 3 steps. So sir 7
नहीं,
और
वो
3
हम नहीं करे. 7 steps और 3 steps नहीं करे. अच्छा, उसको हम कैसे कर सकते हैं? मतलब 7 steps नीचे चले जाओ और 3 steps ऊपर चले जाओ. That's the same as getting here, right? Which is the same as going 4 steps down.
Yes.
That's what we do.
Oh, okay. I got it.
Okay? Yeah. Now, another important effect of this thing is that any point that we have, it can be simply converted to a Pythagoras theorem, and we can easily find the direction or the length using that. So, for example, अगर मुझे ये point है और इस point की coordinates हैं 6 है and 8 है, और इसको मैं कह देता हूँ A. This is my origin O, and I want to find how far is A from O. Then what I can do is that I can simply connect it. I can simply be like that, okay, there is a line going from O to A. So that line is going like that, right? Now that line OA, what is its length? So मैं ये कह सकता हूँ कि आपने यहाँ से O से A जाना है. You're going 6 steps in I, basically 6 steps to the right, plus 8J. That is the vector. So this length is 6 and this length is 8. And you see that this is a right angle triangle, right? So I'll simply apply the Pythagoras formula or Pythagoras theorem. So OA square is 6 square plus 8 square, which basically tells me that OA is square root of this 6 square plus 8 square. Now, if you look closely, what was 6? 6 was the value of X. And what was 8? 8 was the value of Y. So basically, I found that any point can be converted to a right angle triangle where you get X square plus Y square to get the dimension, the length of OA. And not just that, you can also have this angle here. और एंगल कैसे मिलेगा हमें? आपके पास y क्या है? Opposite. और x क्या है? Adjacent. So आप tan कर सकते हो. The tan theta is y over x, 8 over 6 basically. And this is the hallmark of why Cartesian geometry is so much useful when you combine it with vectors. And
Yes,
that's
sir.
like the most difficult level of question that you will get, the most complicated one in O levels, add math vectors. So we're done with the concept as far as that goes.